Welcome. In this video, we begin with some sequences which do not have a formula, and we're going to come up with a formula to express these sequences. Now, this first one, here's a pattern. We're adding 5 here, and here, and here. And basically, any jump we make is always going to be plus 5. So this one's really easy to express. We can express it either by beginning, say, with an n equals 0 term. I'm going to start with an n equals 1 term. So I'm going to begin with n equals 1. So this first term here is our n equals 1 term. So I need to express the number 8 as some number plus 5 times 1. And I say 1 here because I know that my n equals 1. And I have 5 here because I know each term is growing by 5. So 5 plus what will give me 8? Well, clearly this should be a 3 here. So I can continue to do this. Say for this next term, n equals 2, we have 13 equals some number plus 5 times 2. And if you notice, this is 10, and this is also going to be a 3. So I think the only real thing that we need here is to just replace this with an n, and that'll give us every term. So our sequence here is just 3 plus 5n from n equals 1 to infinity. Now for this next one, I'm noticing I'm missing a term here. So I'm going to go ahead and squeeze it in really quick. Maybe you had already noticed that missing term. So I should have a 3/4 here. And now we're good. So we start with 1/2, then we go to 2/3, 3/4, and so on. What is happening? Well, the numerator starts at 1, and then each time we add 1 more. So this one gives us 2. And this one here is 2 plus 1. This one here is 3 plus 1, and so on. So again, I'm going to start by labeling this my n equals 1 term. So in my numerator, here I have when n equals 1, my numerator is 1. If I label this second one the n equals 2 term, when n equals 2, my numerator equals 2. Not surprisingly, on our third term, fourth, and so on, the numerator always matches the term number, so the n. So I know my formula should have an n here in the numerator. Now what about the denominator? Well, the denominator, let's say of our first term, 1 over 2 can be expressed as 1 over, well, our term are in the first term, so I know I want a 1 here, plus some other number. Well, what is the clear choice for that number? Yeah, it's 1. And in fact, if we go here to our second term, to 2/3, I know this is the second term divided by 2 plus some number. And again, you'll see that that number is 1. So that tells me that my denominator needs to be whatever term number I'm on. In this case, for the green, it was 1. And the numerator was also 1. For the blue case here, the second term, we had a 2. So for the nth term, I should have an n here. And we're adding 1 to that. And we're starting from 1 to infinity. I hope this has been helpful.